By popular request, I'm going over numbers 55 and 57 from Chapter 2 in the Practice of Statistics, 5th edition. All right, this is some normal distribution questions, and they are multi-step. So they all have to do with the same situation. So we're dealing with a fast food restaurant, and they're dealing with their lids. They want some flexibility. So in one particular restaurant, they require their lids to be 3.95 to 4.05 inches. The restaurant's lid supplier claims that their lids have a diameter with a mean of 3.98 and a standard deviation of 0.02. So we're assuming that the supplier is true. And you'll notice I drew a nice normal distribution based on what the supplier said. I always go with these normal distributions. If you don't, I highly recommend it. So what I did was I accounted for my z-scores, accounted for my percentiles, and then I accounted for the inches based on the manufacturer's claim. So they said it was 3.98 with a standard deviation of 0.02. So what I also did was I colored in, you'll notice I shaded in specifically where, excuse me, the large cups would fall in here. Because it says large drink cups require lids with a diameter of 3.95 to 4.05. So I accounted for that here. All right, so now the first question I have is what percent of lids are too small to fit? Show your work. So just looking at this, this is why I like drawing these normal distributions. I know it's at least going to be 2.5. I got a little bit more of that distribution right here, right where I colored in pink. So I'm ballparking. I'm thinking it might be around like the 5 or 6 range. We'll find out. But in order to do that, I can use a calculator function. I am going to go with norm CDF. What that does is that gives me the percentage of data values I'm looking for. So I'm looking for all values that are less than 3.95. I'm going to enter in my mean, which is 3.98, my standard deviation of 0.02. And for those of you taking AP stats, it's always good to have lower, upper. And then I'm going to go with mean and standard deviation. Cover yourself. Show your work. So now I get to go to my calculator, which I have right here. Second vars. Takes me to norm CDF. All right, then I'm going to go up to 3.95. So I went with that negative infinity up to 3.95. Mean of 3.98. Standard deviation of 0.02. And let's see what we get. All right, so I'm getting about 0.668. So I'm going to round that to about 6.7. So that's going to be about 6.7%. So 6.7% of lids are too small. Okay. Next part it asks me are what percent of lids are too big? So I'm going to shrink my work down here a little bit. I'm going to go in norm CDF again. I'm going to go with the largest possible lid size, which is 4.05. Go up to positive infinity. Mean doesn't change. Standard deviation doesn't change. All right, so again, I'm going to label. Always label. Earn those points. You always want context. Context is very important for any stats class, not just AP. So now I'm going to go to my calculator again. Second vars, norm CDF. I'm going with 4.05 this time. My upper bound is going to be a bunch of 9s, so I'll account for that positive infinity. 3.98, and then 0.02. And you'll notice I'm getting a very, very low value here. It is incredibly small here. We're looking at like less than 1%, so much less than 1%, so I'll say about 0%. So we shouldn't be getting any lids that are too big, but it looks like we're getting about 6.7 of them too small. Now, it says to compare answers A and B. Does it make sense for the lid manufacturer to try to make one of the values larger than the other? Why or why not? So then you think, okay, well, it makes sense to make the mean bigger. It makes sense to make the standard deviation bigger. That's something to consider here because, let's see, right now, I'm not getting any that are too big. We're getting some that are too small. So maybe if I make that average bigger, maybe I could keep the same standard deviation. Maybe if I went with the same, let's say, I don't know, maybe I went with 4.04 for my mean. Or actually, no, I'm not going to do that. Maybe I just went with a mean of 4. And then I kept my standard deviation the same, 0.04. And then I could keep going down here, 3.98, 3.96. So if I kept my standard deviation the same, but I kept my mean, then, I'm still be in pretty good shape here. The only thing I'm noticing here is that 3.95 is my minimum, and yeah, I think I might still run into a little bit of a problem there, but let's see, because 3.96 would be my minimum, so I could make my standard deviation a little bit bigger, maybe make the mean bigger and the standard deviation. I could, and it says, does it make sense to me try and make one of the values larger than the other? Well, we could see, I think that's part of what number 57 is, but what they're basically asking here is, try some different values, see what happens. So maybe if I went with, I don't know, I'll try one more time. 4 for my mean, maybe make my standard deviation smaller. Well, actually, if I made it smaller, that wouldn't do me much good because that means these values would be higher. So maybe I will make that smaller. 3.98. I'll make my standard deviation 3.9. I'll go with 1. 3.96. And then 3.95 would be 3 standard deviations out. 3.99. 4. 4.01. Hey, if I made my standard deviation smaller, that might be in much better shape here because I could account for, I could easily count for all those lid tops, 3.95 to 4.05. So I can make that standard deviation smaller. Now, maybe they're asking here, does it make sense to try and make any of the values larger than the other? Maybe they're talking about the minimum or the maximum, but I'm just going with the mean and standard deviation. Anyway, I'm going to the big one here. This is where a lot of people had questions. Number 57. And you notice that, once again, I drew a normal distribution that I can use for number 57. I kept some information handy, specifically how big those lids are. That's going to come in handy in a minute because we're going to get some questions. It's one of those questions, it says refer to number 55, so you had all this information handy. If the standard deviation remains at 0.02, at what value should the supplier set for the mean diameter of the large cups so that only 1% are too small to fit? Okay, so now I have a normal distribution here. You notice I didn't put the mean and standard deviation in because we're monkeying around with it a little bit. I'm trying to get a point where I can get 1% of data values that are going to be less, like right in here. So I'm looking here again. It said what value should the supplier set the mean diameter? Okay, and they gave me a standard deviation. I'm going to work with my z-scores here. I'll show you why in a minute. If I use my z-score formula, right? I don't know how many standard deviations away this would be, but I do know what I'm going to be aiming for here. I want at least 1% of my data here, so I want a z-score for that. So I'll use my. Actually, I'll write it down here so I can show my work. Inverse norm, and I want that first percentile, 0, 1. I'm going to enter in 0 and 1 for my standard deviation because I'm dealing with z-scores. So notice I'm going to write area, mean, standard deviation. Always show your work. I'm going to do second vars, inverse norm, 0.01, 0, and 1. I get a z-score of about 2.326. So that's what I'm going to write here. I'm going to give 2.326. So I know it'd have to be about negative 2.326 standard deviations away to get that 1% we're looking for. Now they're keeping that standard deviation the same. They mentioned it's going to be 0.02. So now I'm going to use that z-score formula where I know how many standard deviations away I want to be in this normal distribution because I want 1% of my data values to be less than this value. I don't know what the new mean is going to be. I know what the standard deviation is going to be, 0.02. What value should supplier set the mean diameter of its large cups? Now, I know what the lower bound should be for these cups. I know it should be 3.95. Because the manufacturer specifically said in 55 here, they require lids that are 3.95 to 4.05. So I'm going to incorporate that here. So I'm going with what I know. This is what the this is what the fast food restaurant wants. And we're going to be subtracting this unknown mean to get there. So if I take what the fast food restaurant wants, subtract whatever the mean the manufacturer is going to give me, divide by that still standard deviation, this should be my z-score, so I'm getting 1% of data values less. And now I'm going to have to do some algebra here. So for those of you who don't like algebra, I'm sorry, but you do have to do it. So I'm going to multiply each side by 0.02. So that way these can cancel out. And I'm going to have to jump to my calculator here. Times 0.02. I get about negative 0.0465. So I'm just rounding here. Negative 0.0465. And that's going to be 3.95 minus whatever this mean is going to be. I'm going to subtract each side, 3.95. So I can isolate my variable. 3.95. I'm getting about 3.996. So we'll go through like 3.997. I'm just rounding here. 997 equals negative mu. And of course, we know we can divide each side, multiply each side by negative 1. And I get about 3.997 inches. Should be that new average if I specifically want 1% less to be too small. So again, what did I do? I looked for 1% on my normal distribution. I specifically identified how many standard deviations away I had to be to get 1% of my data values less. I did that using inverse norm, and then I used that z-score, plugged in the value I knew, that 3.95 inches. I know that's the smallest that those largest can hold at that fast food restaurant. Did not know the mean. And then I went with that standard deviation that we already knew. So that's what got me to part A. Now I got to get to part B. Now they're telling me if the mean stays the same, what value of the standard deviation will result in 1% of lids being too small to fit? Okay. So again, I'm going to use that z-score I already have because I know that will give me 1% that are too small. That's not going to change here. So I'm going to plug it in. Negative 2.326. Specifically said too small, right? Just want to double check. Yep. So I'm going to go with that again. 3.95, that's not going to change. They're giving me a new mean, I believe, here. Yep, 3.98, but I'm not getting the standard deviation, so I'm going to have to do some backwards algebra here. Okay. So in order to do this, I can multiply each side by sigma. Then I get negative 2.326 times sigma, or my standard deviation rather. 3.95 minus 3.98, which I shouldn't be doing this in my head. You should always show your work. But I'm going to go with negative 0.03. Divide each side by negative 2.326. And let's see what we get. I have to plug into my calculator. Negative 0.03 divided by negative 3.326. And let's see what we get. Oh, about 0.0128 or 129. So it tells me my new standard deviation would have to be about 0.129 inches to account for that. So that's telling me if I keep that 3.98, I want 1% to be less. I just have to change that standard deviation to 0.129, and that'll give me 1% being less. Now I just want to double check to make sure I'm not missing any parts of 57 here, but I think I'm pretty much covered. So you can tell drawing these normal distributions should be, part of your routine when you're doing normal distribution problems. It can help you really visualize things. You'll notice I use them a lot. Oh, and there is a part C. It says, which of the two options do you think is preferable, and justify your answer. And be sure to consider the effect of these changes on the percent of lids that are too large to fit. Okay, so now what I would have to do is, let's create a normal distribution based on these new values. So I'm going to go with 3.98. I'm going to add that 1.129. So I'm just going to do some quick math here. 3.98. I'm doing this in my head. I probably really shouldn't be, but I'm too lazy to take out the calculator again. I'm not going to lie to you. All right, so 109, and then again 238. I think that's about right. And then 3.98 minus 129. I'm going to need a calculator for this. I probably should have just rounded to 1.3, but that's all right. So I got 3.851. Now here's what I'm noticing. If I do that, I change that, right? Already using this new standard deviation. Oh, I think I did my math badly. Yeah, I did. Whoops. It's all right. I'm thinking that looks really bad. That's why we double check ourselves. 3.98. And am I using the right value here? Double check my calculator. It's 0.0129. Whoops. Hey, we all make mistakes. That's why we do this. So what I'm going to do is I'm going to have to redraw this, but that's okay. Again, I like showing mistakes. It shows us that we're all human. All right, so what I can do is I can just go with like 0.399. I'm just going to round just for the sake of it. 4.0. It's close enough to 0.01, right? For the sake of what I'm doing, it should be fine. If I really want to add that 3, I can. Then, yeah, 6. There we go. Why not? And then subtract 2, so then I'm going to have to go back. 3.97. And then, what is it, 7. You get the idea. I'm doing math really quickly here in my head. I probably shouldn't be, but I'm just doing this to prove a point. That you probably shouldn't be doing math in your head. That's probably the point I should be proving right now. But what I'm trying to demonstrate here is that I'm noticing that if I keep going back, I got a lot more lids here. If I change that standard deviation, I'm going to have a lot less lids that are going to be too small. Because that 3.95 is going to be over here, and all those new lids that could be too small are going to be all the way over here. Whereas if I go with that new standard deviation, let's say, or if I go with that, go back up above here, right, calculate the new mean of about 3.997, which we're going to say for the sake of my drawing is just going to be 4. But again, we kept that standard deviation here. Let me go back up here. Standard deviation we kept was 0.02. So if we keep going, like 4, 4.02, 4.04, 3.98, 3.96, and ooh, believe it or not, this is going to actually be pretty close. So what I'm going to have to calculate here is what percent are going to actually be less. I'm going to actually have to do some work here, but that's okay. So I'm going to go inverse norm. No, not inverse norm. I'm going to go norm CDF because that's what you do for the find area. As you can see, this problem's a little bit involved. That's why I wanted to do it in a video instead of doing it in class. There's a lot of work involved here. So first thing I'm doing is going by changing the standard deviation, which we got 0.0129. What percent are going to be too small? We'll find out. Second. Negative 99999. 3.95. I'm going with a, what am I going with here? Try first, that's right, 3.98 and 0.0129. And then 0.0129. Let's see what percentage I get. Syntax error, oh come on. We're all human, aren't we? One more time, 3.95, 3.98, and that new standard deviation we calculate, 0.0129. Okay, that's exactly like, it's like 1%. Okay, see if that value gets any less when I plug in the new mean. So norm CDF, we're going to go negative infinity again. That new mean I calculated up above, I got, let's see, 3.997, so I'll just go with 4. So once again, I'm going to go with 3.95, 4, and this one was keeping that old standard deviation of 0.02. Let's see what happens. Again, you should be labeling your work. I'm just doing this for the sake of a video, but if someone were grading me, they should be taking off points. Second, vars, norm CDF, all those 9s again. 3.95. Now I got a new average of 4, standard deviation of 0.02. Let's see what happens. Oh, wow, a little bit less, just a little bit. So it looks like I would be better off changing my average to 4 than to changing that standard deviation. That's what you're trying to prove here. Which are you better off doing if you want, less lids that are too small? And what I found was, when I went with that new standard deviation of 0.0129, the second part of the question, I ended up with about 1% of lids being too small. When with that new mean I calculated of 4 and kept that old standard deviation, I ended up with about slightly more than 0.5%. So either way, I'm not going to have too many lids that are too small, but changing that mean will ultimately change things. As you can see, this was a pretty involved problem. I used a lot of drawing, I used a lot of problem solving, and I used a lot of calculator skills. So this is a really in-depth problem when it comes to normal distributions. So if you had some trouble with it, it's okay. But hopefully my thought process and even my mistakes, hopefully they helped you along the way and helped you learn how to do a problem like this. Best of luck.